Hi and welcome back to the lab. And today here on the bench we have the Yaesu FTDX101MP. So that is a 200 watt version. And the radio came in because it is not possible to switch the radio on. So we see that the radio is drawing some current, but other than that it happens nothing. It is more that our power supply seems to switch off. So something is really wrong. So let's see what we can do. Okay, and here's our FTDX101MP, and as you may know, the speaker which is here connected is not only the speaker, so that is the power supply, because the 200 watt version needs 50 volt here for operating our power amplifier inside, and therefore we have here a special switching mode to a power supply, of course, inside our speaker housing, right? So now when I switch it in, you will see that we have some funny behavior, but you do not really see here something because nothing happens here on the radio. So the only thing what we can do is watching our power analyzer, and then we see that definitely something is going on, and we see after a very short while that the radio switches off. Okay, so therefore let's go right into that. Now I switch the power supply in and let us see what happens. Okay, so you see something is going on here, and then suddenly it collapses. So it is definitely down to almost nothing. So I switch off my power supply, and that is telling us, okay, something is really wrong. And now one could say, hey, possibly there is a problem with the power supply. Yes, that is true. That could be the problem. But this here is my lab power supply, which I always use for working on these radios here. And so I'm sure that my power supply itself is working perfect. So that is not the problem. We have definitely a problem here with our radio. And therefore, yeah, let's see what's going on here. Well, and since we know that the power itself goes in, or let me call it over, our power amplifier stage. So there is where we get our 50 volt in. So, and that is the first point where I'm going to look if we can see something obvious. Okay, and here we have it. So here we have our power amplifier. Here our low pass filters and so forth. And of course here on the right side we have our both RX units, A and B, or 1 and 2, whatever you want. But as you can also see, here is our power supply wire, and that goes here directly into our radio, and you see here the red wire which is running here into the radio finally. So that means that is the first point where, you know, our 50 volt gets in contact with our radio. I mean, of course it gets distributed from here, but because we have seen that our power supply is switching off quite quickly, I would consider that something might be wrong with our power amplifier. And therefore, let's have a look how it all hangs together in our schematic, and then we can decide how to go on. Okay, and here you see a part of our PA board. Important for you is, of course, here our input. And you see it is really our 50 volt, which gets delivered from our special power supply. And of course, if we follow here along, we relatively easy gets here to our power amplifier stage, so at least our final. And you see here our VRF 150, by the way, very expensive transistors. So they get supplied directly by our 50 volt. And the supply line is very simple, so it gets here directly from our power supply. Here it gets split in two lines here over our FB6005 and FB606. And then you see over our transformer here, it gets directly delivered to our drain of our transistor, right? So both sides, of course. This side here and the other one is going here, and then goes to the other transistor. So both transistors are connected to 50 volt. So that is how it is arranged. And well, I've very often seen that something is wrong with power transistors, and therefore let's really check what we can do in circuit. And here are our power MOSFETs. And well, the first what we can do without doing nothing else is checking, the resistance in circuit from gate to source. So that is the first what we can do, and let's check that. Okay, and I think we can see everything that way. So let me start here at our left transistor. Let's see what we got. 25 kilos, so that is familiar. And let's check it the other way around. 25 kilo, that is exactly what I expect. Let's see what we get to drain. gate to drain, 25 kilos. So that is exactly what I expect. So let's see what we get here on the right one, which is, oh, look at this. So there must be, you know, a way. So that is only 1 kilo, as you can see. Let me check the other way around. Yeah, you see, that is definitely wrong. Let me check from gate to drain. Okay, so that is exactly our problem. So we see that, you know, obviously here our right transistor is blown. But we can prove it when we disconnect our, you know, output power, not our output power, sorry, our supply voltage from the output stage. And then if it is really our transistors here, which I believe, because we have seen the short, right? And that makes it clear, because our radio protects itself, right? So, of course, there is a current sensor which is telling, you know, the processor that there is something going on which is wrong, and therefore the processor will switch off the power supply. So, you know, that is totally fine, because then nothing other can get damaged, right? So, but when we disconnect now our voltages from our final stage, then if everything is fine, then we definitely should see the radio running. So let's check that. Okay, so I have simply disconnected here our FB606 and 605, which are these guys here. Now we do not get voltage to our amplifier stage and final stage. And now let us check if maybe our radio is working. Okay, and of course it is the same game. Let me simply switch on the power supply and let's see if our radio, or the processor at least, switching off our power supply again, or if the radio is running. So let's see. Aha, hey, here we are. So you see, everything is back. So, and that is now definitely the proof that our final is faulty. So what we need now to do, we have, of course, take our PCB out, and then we can arrange to get, first of all, of course, here, our faulty transistor out of circuit. And then we can, of course, check the transistor in our component tester, but we have seen the short, so therefore it is quite obvious that the guy is dead. So let us put or take the board out, and then we go ahead. Okay, so all the screws are out, and we have quite a bit, and that means we should be able to lift the board. And yes, we are able to lift it out. So we need to be careful not to damage here something. So, but as you can see, yeah, job is done. All right, and here is our power amplifier board on the bench. And the first what we want to do is take here our most suspect transistor out, and then we can go ahead. All right, and well, it is always a discussion what might be the gentle way, or the gentlest way to get the transistors off our board. I mean, okay, we could do it with hot air, but that is maybe not the most gentle way to do it. So I try to suck as much of the solder first of all away, and then we hope that we can gently take it away. And we already see that we have again a lot of ground plane here to get over. So that means we need to take our normal soldering iron and try to lift it up now a little bit. Well, not sure if I really can do it here around the camera, but let's try. Otherwise I have to do it without the camera in the way. But let's try. Okay, but here it is already nice. So maybe that is not so much we need to do. That is almost loose, but here, guys, I'm sorry, I need the camera out of the way. And what you can see, finally, our transistor is out. You know, the ground here is really heavy to overcome. So therefore, I've used here a little bit low melting solder. So that makes the process much easier. And you see, yeah, it is off now. And very important as always, so we have no damaged pads here, which is more or less very, very important to achieve that. And yes, from here we can go ahead. I mean, of course, we clean now our pads and we check our transistor on the component tester. And if everything is clear, then of course we need to do exactly the same to the second one. So, and as you can see, our pads are fully intact, and if you give too much heat to it, then there is really the chance that you lift up, you know, your pads, and then that is real trouble. So I really only can advise you not to do this job if you do not have the right tools first and the experience to do it. And you know, everybody does it a little bit different. So everyone have his own method doing it. I have mine, and you know, the outcome is what counts. And if the pads are fine, then everything is good. So I know that some just simply try to cut here the leads. You know, I've seen that also brings stress to the board, and I do not really like that method. Always a Dremel or so, you know, that all is possible, but I don't like it. So if you have good experience with it, and you have a good outcome, fine. I do it this way, and I'm quite happy with it. So that is important to know, because I'm not sure if there is really one golden way, right? So you must find how to handle it. Okay, so I've connected my tester to the component, and let's see what the result will be. Okay, so green and blue leads are shorted, and look here where we have green and blue. So that is gate, and it is drain. So you know, that is exactly what we already tested in circuit. So therefore, yes, that is a proof this transistor is broken. Okay, as you can see, both transistors are out, and you see everything is clean. So we are ready for replacing the new transistors. By the way, the second transistor, this one, so what we take out, what we have taken out last, is testing fine. But the gold standard telling we always have to replace both, since we do not know what really happened to the unit, and therefore both. And I have here already the original part. So the VRF 150, so new transistor directly from Yaesu. That is now to replace it here into our unit. And as you see, nicely packed in ESD, and so we can be sure that they both are fine. Therefore, let's go ahead. And not sure how often I have told it in earlier videos, so it is essential to align it in the right way, okay? And therefore we need to put it back into the chassis, then put our screws in so that they are really aligned, and we do not have any problems when we put it really back, that all, you know, the holes are fitting with the chassis. So therefore now we put it first into the chassis, we put two screws in, and then we can tuck two leads to have it really in place, and then we take it out again, because we don't need, you know, all the ground plane. So therefore this both, I mean, drain and not drain and gate, sorry, source, which we have on both ends, are really connected with ground, and that is really the problem. So therefore we tuck gate and drain, which is much easier to solder in chassis, but then we take it back out and do the rest. And you see, here is our chassis, so let's put it back here. So look, our transistors are now exactly in place and aligned. So we have the two screws in on both sides, of course. And of course we have fixed the board as well with two screws. So that's the board itself, so you can see it here, right? So there is one screw in, so that the board itself is aligned. And then secondly, that we have our transistors aligned. And now we can tack it, and then we take it back out. And as always, we put flux here to our transistor. So that is very important, that everything works out well. And then we are almost ready to do the job. All right, so then as example, we do one together here, one lead. And as you can see, even that there is no real ground we have to overcome, it is still not that easy. But you see, that is how it works out, and that is fine. So we do that now on our rest 3 leads, and then that's it. We can take our boat back out. All right, the new transistors are in, so let's get the PCB into the chassis. And of course, we clean first off here all the old heat sink grease, and we put some new to our transistors on the board. And everywhere, of course, we put some new here, and that is then fine, and of course ready to go. That's it, not too much, just a little bit is just fine for this process. Okay, so everything is back together, and what we need to do, of course, is setting here our bias to almost 0, so we do not want to have a current flow through our finals, and the same with our pre-finals, and of course with the not final driver, of course. So that is okay. They are all down at 0. Everything is connected so far. That's fine. So okay, let me connect our wire here towards our power supply. Now let me switch in power in general, and now let me switch in radio over our power supply. And yeah, that is now moment of truth, so cross fingers that nothing goes wrong. So 1, 2, 3. Hey, oh wow, it's back. Yes, it is back. So that means first step is definitely done. Very, very nice. So no shortage any longer, and you hear we have static, fine. Now let me prepare everything that we can adjust our bias. Let me see what it is all set. Okay, so what we need to find is a lot of reflections here. So hang on a second that we can better see it. Okay, so I set it this way because then we can see it a little bit better here. So the first what we need to do is to reduce our mic gain to 0, because we do not want to get any audio into our radio. Now we are at 0. Mic gain is 0, fine. And then we need to make the connections at our power amplifier PCB. According to our service manual, I have now terminated input and output both to a 50 ohm load, so that we really have the right impedance setting here. All right, so what you see, we have connected here our setting for our pre-drive stage idling. I have to set the radio now into transmit, which we have now, and since I have any or all the potentiometers closed, so we do not see a current flow, let me go down here to the little pot, and what we need is 100 milliamps. So let me turn here, so that is microamps what we read. So of course we need more. That is already 1 milliamp, 5, so 10, 30, 40, 60, 80. Okay, too much. So we need 100. So come on, 100 milli. And you see again, all these potentiometers are very touchy. And that is what we see here as well. So we need a lot of patience to get it to the right setting. What is plus minus 20 is 100 plus minus 20 milliamps. Okay, so that would be already in spec, but let's try to bring it as close as possible. So 95 milliamps is just fine. Once again, we have plus minus 20, so that is fine. And as you may see, so we have already replaced here our probes to the next test point, and now we have to adjust our driver stage idling current. So before we had pre-drive, and now we are at the drive stage, and that are at least 2 pots, because we have 2 transistors, and we need to go from one and add the second one, right? So that is what we're gonna start now. Let me check which one we need to turn first. Okay, so first is VR2, which is the guy down here. So let me set the radio back into transmit. which we have now. And the setting is now for each transistor, it is 800 milliamps. So that means first we adjust 800 and then we go over and adjust 1.6 amp. So then both are in the right alignment. So let me start here with that guy. Let's see. Yes, it's working. Okay, 800. So that is already a bit. 600. And let me go closer. 800. 817. So, and yes, of course, it is here exactly the same. It is touchy, and therefore we really need to do it in peace and quiet. So what is our plus minus 100? So we have plus minus 100. So that means we are fine here on this side. And now we take our seconds, VR3, and we go up to 1.6 amps. Already too much. 1.6, and that is almost spot on. So it is the tolerance is plus minus 200, and we are spot on 1.6 amp. So that is fine. We can stop transmitting here, and we go ahead. Okay, so now we go over for our final alignment, and that will show us as well if our new transistors are working. Because if we are not able to adjust, our bias or idle current, then something is wrong. Okay, so we have to start on the 6004, and yeah, let us set it to 450 milliamp each. So that is good. I mean, we have plus minus 100. Very nice. Okay, so let me set the radio into transmit, and we already have 5 milliamps. Let me check if both are really close. Yes, they are. Okay, so let's go for let's say 450 approximately, and I assume that they will be touchy as well. Let's see. Okay, it's coming up. Oh, very nice. So that means our first transistor is working. Okie dokie, let us set it to, that's a little bit too less. A little bit more would be fine. 468 is nice. Okay, so let me take the second one. Okie do. Let's see if it comes up. Yes, it does. And let's go to 920, I believe. A little bit better. Come on. Too much. Oh, that looks nice. Alright, so both new transistors are working right from our idle adjustment, so we know that we can influence the current flow, and that is almost telling everything. So that means now we have to take away here our load resistors, our dummy loads, where we terminated our board with. We bring all back in the right condition, and then, yeah, let's see if we can really get our 200 watt out of this radio. Okay, so everything is prepared for testing. So let me switch in the power supply. First step, now let me switch on the radio. Second step, looks good, pretty nice. For testing, let's simply set it to FM because we can test our carrier. So we do, so that is the easiest way to do it simply. Okay, but first, let me reduce the output power. Let me reduce it, to minimum. Let's start small, and let's set the mode as set to FM. Speaker a little bit lower. And now let's see what we will see on our LP500 when we press MOX. Hey, 4.9, and look to the SWR. So that is an interesting thing. If you look different radios, okay, much cheaper radios, then you always see that, you know, the SWR is 1.3, 1.6, 1.7, but the high-end radios are all very, very close to the impedance. So that is remarkable. And here we have exactly the same. Okay, so 5 watt, fine. Let's say we go up to 10. So 10 watt, let's check what we have. And exactly the same, very, very nice. Look to the SWR. Okay, so that is working good. Let me go up, let's say, to 50. looks everything fine as far as I can see. So let's, yeah, 47. And again, look here. So that is really remarkable. Okay, and let's go to 100. And let's check. Yes, perfect. And 150. Let's see, that's a little too much. Okay, and that is fine as well. And let's go up to maximum power, which is 200 watt. And let's see what we got. 192. You see, it is always slightly below. And I really like the setting. It is never good to put maximum into, you know, or yeah, you should never really run your finals at the maximum, because think about that all the heat needs to be think, and you know, radios are getting hot, and therefore it's always good to be a little bit below the limits, but do not exceed the specified limit. So that's not a good idea. Again, once again, when we again see here our SWR, compare it with cheaper radios, and you see how nicely that is designed. Okay, anyways, radio is back working, everything is fine, everything is aligned. The new power amplifiers which are in are from a different company, so I believe the older one were a bad batch. So I truly believe that the new amplifier transistors lasting for longer, so now we can bring it all together and it can go back. Yes, we are at the end of our video, because you have seen everything what is important. Hope you learned something, and catch you next time. Bye.